Hello friends, I am Ashish, your instructor. Now we will understand the most important feature, vPC. Why do we use it? What it is, in fact what it is and why do we use it? So it's a virtual port channel. You know about the port channel? The traditional. Let's say that if you have this device and this device, as per the port channel rule, let's say that these are the two links I want to combine. I can do it. Means I need to move this port and this port into port channel, let's say 1, and similarly this two. The configuration, that is speed, duplex and other things, means the configuration has to be same on both ends. Okay, and in but if you have this kind of scenario, let's say that these are the two switches and this is third switch. Okay, so can you combine this port and this port virtually? You can't, because there's a rule that the connection from one chassis should go to other chassis. It cannot split. Okay, so if these are two different switches, we cannot do it in the traditional port channels. So we have come up with the concept of vPC in Nexus devices only. So it is possible in Nexus. Okay, so in the Nexus devices, we can do it. Let me show that to you. This is switch 1. There are few things that you need to know on setting up the configuration. Okay, so if this kind of scenario is there, we just need to have one vPC peer keep alive. Second is vPC peer link. We can form a port channel. We have to form a port channel. Even if there's only one link, we have to form port channel for vPC peer link. Okay, and then we'll create one port channel and move this port, in this case port number 1, in this case port number 2, into port channel, and then we'll, let's say port channel 1, and then we'll move that port channel into vPC. So these two switches will appear as a single switch for this switch. Okay, logically it's logical. So port channel, logically it'll act like this. Okay, or let me draw a better diagram for you. Logically, if you have this thing, this will be the logical, this is okay, this will be the logical way from this switch, even though these are two different switches. So that's the vPC is in layman terms. And other thing that you need to know about is that the traditional port channels, okay, that we discussed, these are layer 2 plus layer 3, means you can have layer 3 port channels as well. But vPC is only layer 2, it is not layer 3. This is the first thing. vPC works only on the Nexus devices. Okay, the downstream device can be server, it can be a server, it can be Nexus 7K device, 5K device, or 4500, 3750, whatever. There's a there's a further rule in vPC that vPC peer keep alive link has to be minimum 1G. Okay, and peer link, it has to be 10G, and peer link has to be part of port channel. It is mandatory, else you will not be able to use the that command to move it into vPC. So these are, and you have to configure vPC domain number has to be same. sorry, domain number has to be same. It can be 112233. Only then you will be able to unite these. Only then. So these are the basic things. And in the VPC, LSCP will work only plus on feature, which is by default means enabling the port channel. There is no concept of PAGP. It is not there in VPC. But in case of traditional, you'll find it. Okay, one more thing about it. You have to enable, first thing, enable feature of VPC using feature command. Second, if you want to use LSCP, use the LSCP feature. And in case you are using SVI interfaces, then use the interface VLAN feature. Okay, so feature has to be enabled. You also have the has to have the license which is needed for VPC. So this is all about VPC. Means ultimately it will unite, it will make a logical formation of these two switches, so that the ports which are in different chassis can be bundled. That's the main. And people ask question, how it is different than VSS. See, VSS is a concept of 6500 switches, or probably 4500, where you basically combine the control plane of two different chassis and manage it from the single. Okay, but in case of VPC, you have to configure this feature manually on both. Okay, and these work individually. You need to know it. It is not like you are managing this device from one. It is not like it. You have to configure VPC, and it is only for port channeling. That's it. Okay, only for port channeling. You need to remember it. Layer 2. This is the rule. You cannot configure routing protocols over it. No layer 3. VSS only for 65 4500, and it basically combines the control plane or supervisor modules. I don't know much about VSS, but VPC is only for port channeling, and it is a feature of Nexus. Upstream devices have to be Nexus devices. Downstream can be server traditional switches like 3750 or 3800, whatever switches. But upstream has to be. So one switch will act as a VPC primary, one will act as VPC secondary. When primary goes down, secondary will take over, but in actual the data will work on active. Okay, this is the concept here. And when VPC peer keep alive link goes down, the first link, let me use a different color. When VPC peer keep alive link goes down, let's say this is the link, if it goes down, VPC will keep on working. It will basically stop the split brain. How it will stop it? The fundamental is very simple. There's a VPC primary and secondary. When there is a layer 3 connectivity problem of VPC peer keep alive, the secondary Nexus will move all of its member ports into suspended state, so that there is no connectivity loss. This is the benefit. But if the VPC peer link goes down, your VPC will stop. So that's the reason we recommend that there has to be multiple links into VPC peer link port channel. That's very important. So friends, we'll do the practical configuration as well, so that you understand it better, and I'll discuss many cases because this is very important features. So I hope that it's been informative to you, and I would like to thank you for viewing. Have a nice day.